Today we want to start with projectile motion continuation part 4. So we stop at projectile in two-dimensional projectile. So we want to see time taking to reach the maximum height. Time taken to reach the maximum height. Let's see the time taken to reach the maximum height. From V is equals to U plus 80. From V is equals to U plus 80. We are dealing with vertical. Time taken to reach the maximum, so it will be Vy is equals to Uy minus Gt. And remember, Vy is equals to 0 meter per second at maximum height. We have done this. The velocity of the body projected vertically upward at maximum height is equals to 0 meter per second. So our Uy, we have derived it, vertical component of initial velocity, as U sine theta. So let's substitute there. 0 is equals to U sine theta minus Gt. And our Gt is equals to U sine theta. We have transferred this to this side. Divide both sides by G. We have T is equals to U sine theta all over G. This is the formula for finding the time taken to reach the maximum height. Immediately after that, we want to see total time of flight. Total time of flight, or time of flight. We have defined this as the total time spent by a projectile. That as the total time spent by a projectile in air. Meaning T is equals to the time taken for upward motion is equals to the time taken for downward motion. So it will be T plus T. So T is equals to 2T. Our T is equals to U sine theta, so it will be 2U sine theta all over G. This is the formula for finding total time of flight. So let's see maximum height attained. Maximum height attained. Maximum height attained. Maximum height attained. From V square is equals to U square plus 2AS. This is what we have. So how we are dealing with vertical, it will be Vy square, Uy square minus 2GH. So at maximum height, Vy is equal to 0 meter per second. Velocity is equal to 0. So 0 square is equals to, and recall Uy is U sine theta, then everything squared minus 2GH. 0 now is equals to U times U squared. Sine theta times sine theta, we have sine squared theta minus 2GH. Transfer this to this side. 2GH is equals to U squared sine squared theta. So what is H? H now is equals to U squared sine squared theta, everything over 2G. This is the maximum time. This is the maximum height attained. So there is another way of proving that. Let's see why question. There's another way. Given that S is equals to ut plus half at square, and t is equals to u sin theta over g. Time taken to read the maximum height. Prove that maximum height is equals to h u square sin square theta over 2g, instead of using v square is equals to u square plus 2h as we have done. So let's see, from s is equals to ut plus half at square. So here we want to calculate s to be h. U, we are talking of vertical, so to be uyt minus half g t square. Remember, it is minus g. So h is equals to uy, know that to be u sin theta. So multiply by t, that is u sin theta all over g. It's given. I'm taking to reach the maximum height. Then minus half g t squared. So u sin theta all over g squared. That is, so we have h is equals to u squared sin square theta all over g minus half g times u squared sin square theta all over g squared. When you open the bracket, so g will cancel 1. We have h is equals to u squared sin square theta all over g minus u squared sin square theta all over 2g. So you can find the SCM, that is 2g. This will give you to 2 u squared sin square theta minus u squared sin square theta. U squared 2g into g 1. So you have h is equals to, when you take 1 out of this, you have u squared sin square theta everything over 2g. This is another way to prove this formula. Our next quantity to be determined is the horizontal distance. The horizontal distance. The horizontal distance. This one we call it SX, horizontal distance. How do we determine the horizontal distance? From S is equals to ut plus half at squared. So Sx will be uxt plus half gt squared. But try to recall that g is equal to 0 meter per second square for horizontal component. So horizontal component of acceleration due to gravity is 0 meter per second square. For that reason, Sx will be uxt then plus half times 0 times t squared. So everything Sx now will now be uxt. Our ux is u cos theta. So u cos theta times t. So our Sx now will now be ut cos theta. This is the formula for finding horizontal distance where it has not attained the maximum height. So this one is time dependent. So it is time dependent because it depends on time. We call it time dependent. So let's see the formula for the vertical distance. The vertical distance. The vertical distance. For vertical distance, we call it SY. SY. From the same equation of motion, S is equals to ut plus half at squared. Then so far we are talking of vertical, it will be SY is equals to uyt minus half gt squared. We are talking of vertical, acceleration will be equals to minus g. This is what we have. Then recall that uy is u sin theta. So u sin theta times t minus half gt squared. So the formula will now be sy is equals to ut sine theta minus rgt squared. This is the formula for finding vertical distance. You can see the vertical distance is time dependent again. This one is also time dependent because you have t here, you have t here. So it is time dependent. So we have seen the formula for horizontal distance. We have seen the formula for vertical distance. Let me still remind you, what do you mean by horizontal distance, vertical distance? When a body is projected vertically upward, this is the trajectory. You know, from here to here is the range. We call it the range. So, when it has not reached the maximum height, the distance from here to here, we call it SS. That's what we call horizontal distance. While the corresponding vertical distance, we call it the XY. That's the vertical distance. So, we want to calculate not the range this time around. So, that is why this from here to here is maximum height, which we have done that one. We have done that one. That's the formula. Vertical velocity, final velocity, vertical, call it Vy, vertical velocity. Then from V is equals to U plus 80. We say Vy is equals to Uy minus GT. So far we are dealing with vertical to be Yy. Y is minus G. What is Vy? That's what we want to get. Is equals to Uy is U sine theta, then minus GT. This is the formula for finding vertical velocity. You can see it depends on time. We have it. This is time dependent. This question was asked in WASE. Go and check past question. WASE 2023. You have to find the vertical velocity of a body projected vertically upward and show that it is time dependent. It depends on time. This is how to show you. While horizontal, let's see horizontal components. Horizontal velocity, component of final velocity, we call it Vx. Then the same thing will happen. We say from V is equals to U plus 80. So while we are dealing with the horizontal, it will be Vx is equals to Ux plus GT. But G for horizontal is 0 meter per second square. We've said that. So Vx now will now be Ux, that is Ux is U cos theta, then plus 0 times T. So our final answer will now Vx is equals to U cos theta. This is the formula for finding horizontal final velocity components. And it is time independent. It is time independent. It does not depend on time. You can't save time here, meaning it doesn't depend on time. So that's the formula for finding that. So immediately after that, we move to Mr. Range, the range of a projectile. The range of a projectile. We have given the definition to be this is the distance. This is the distance of this is the horizontal distance. It's better to call it horizontal distance. This is the horizontal distance covered by a particle or a projectile from the point or from the plane of projection, to the point of landing, That is the definition of the range. If you remember the diagram, where we have it like this, from here to here is what we call the range. This is the point or the plane of projection, and it lands here. So the horizontal distance from here to here is what we call the range from S is equals to UT plus half AT squared. You know, S we turn to R, U we turn to UX because we are dealing with horizontal. While T will be capital T. Why is it capital T? Remember, you want to calculate the total horizontal distance. Time taken for upward plus time taken for downward. So you are going to make use of capital T. And our A is equals to G, which is equals to 0 meter per second squared. Because there is no horizontal component of acceleration due to gravity. So for that reason, let's come back. R will now be UXT plus RGT squared. But this one is 0 meter per second squared. We have said it. R now will now be UXT. Then plus everything will be 0. So R now will now be UXT. Then recall that our UX we have derived that is U cos theta. And the total time of flight we derived that one to be 2U sin theta all over G. So you combine this together, you have 2U squared sin theta cos theta. U times U will give you U squared, then we have 2 here sin theta cos theta. Everything all over G. But recall that in trigonometry, sin 2 theta is equals to 2 sin theta cos theta. So anywhere you see sin 2 theta, 2 sin theta cos theta is same thing as sin 2 theta. So our range now will now remain U square. 2 sin theta cos theta is sin 2 theta, sin 2 theta, everything all over G. This is the formula for finding the range of a projectile. We have the maximum range, the maximum range, the maximum range, call it R max, the maximum range. You know, from the equation, R is equals to U squared sin 2 theta all over G. That's the formula. Now, clearly, R is directly proportional to sin 2 theta. So, R is maximum when sin 2 theta is maximum. And sin 2 theta is maximum and sin 2 theta has the maximum value of 1. Anytime you use your calculator, often you got able to look for sine of an angle, you cannot get any value above 1. The maximum is 1. You cannot get 1 point something. No, it's 1. So for that reason, let's look for the theta. Sin 2 theta is equals to 1. 2 theta is equals to sine inverse of 1. 2 theta 9 is equals to sine 90 degrees give you 1. So definitely it's 90 degrees. Then theta 9 is equals to 90 degrees divided by 2. So theta 9 is equals to 45 degrees. So the range of a projectile is said to be maximum. When the angle of projection to the horizontal is 45 degrees. That is, theta must be equals to 45 degrees. Then we say the range is maximum. So from this formula now, I can say R maximum will now be U square sin 2 theta 9 is 1 all over G. So R maximum range, the formula is U square all over G. This is the formula for finding maximum range, U square all over G. So we've been able to derive all the formula involved in the projectile. We'll give the summary in a tabular form. Let's see the table like this. Let's say you have the quantity here. Then we have the formula. We have the formula here. We have the quantity. We have the formula. Number one, we want to see initial horizontal is u cos theta. 2, uy is u sin theta. Is u sin theta. 3, we derive time taken to reach the maximum height. We call it u sin theta all over g. We derive total time of flight to be 2u sin theta all over g. 2u sin theta all over g. 2u sin theta all over g. Five. Maximum height h maximum we derive to be u square all over 2g. That's the formula. Again, number 6. Horizontal distance. We call it ut cos theta. Vertical distance s. We call it ut sin theta minus half gt squared. We talk of vertical velocity vy, which is u sin theta minus gt. We talk of horizontal velocity, final velocity, that is vx. This one is given to be u cos theta, is independent of time. Then we talk of range. The projectile range r, that is r. That r is given to be u square sine 2 theta, everything all over g. Then we talk of maximum range. We talk of u square all over g. Then we talk of angle theta at maximum range. Then we call it 45 degrees. This is the summary of what we have done so far, and these are the formula we do apply in solving problems in projectile. So our next video will be the last aspect of projectile, where we are going to use all this formula to solve 2 or 3 questions. Please comment, like, share, and subscribe. God will bless you as you do that.